Hey, hello and welcome to today's GFG problem of the day. Hope you're doing well. So let's say today's problem, nth natural number. So what the problem is saying is we'll be given positive integer n and we have to find nth natural number after removing all the numbers containing the digit 9. Okay. So what the problem is saying is, for example, if n equal to 9, right? If n equal to 9, so we want to find the nth, that is the ninth natural number, the ninth natural number, okay, after removing the digits which contain 9. For example, right? For example, what will be the ninth natural number, right? One, two, if we start from one, right? 1, 2, 3, 4, 5, 6, 7, 8. And we have to exclude 9 because definitely, as the problem is itself saying, right? Then what number comes after 10? After 9, it comes 10, right? So if we count, so 1, 2, 3, 4, 5, 6, 7, 8, and this is the ninth number. Okay, and the ninth number is 10. So we want to return this out as output. Okay, this as output. Okay. Now, I hope you have got the problem. Now, how can you solve this problem? So let's first see the brute force approach. So simple, what we can do is we will have a while loop, right? We'll have a while loop. Okay, we'll have a while loop and we'll have an this I, right? This I. Okay, this I. Now, or maybe we'll have a count variable. Okay, count variable which will start with 0. So count should be, we'll run this while loop till count is not equal to n. Okay, and also we'll have int I equal to 1. Okay, so we'll keep on running this while loop, okay, until this count is not equal to n, right? And we will, for example, we'll also check whether I mod 9 for, or not mod 9, basically we'll have to run a logic wherein we'll have to check whether I contains 9 or not. If it contains 9, we'll simply ignore. Okay, otherwise we will increment the count. Okay, but this approach, it is going to take us what? It is going to take us, it is going to take O of n. Okay, O of n as a time complexity. Okay, and if you see, the expected time complexity is O of log n. Okay, okay, so now we have to think of some better approach, right? We have to think of some better approach. So for example, now whatever this number is given, right? It is base 10. It will be a base 10 number. For example, if you want to convert a base 10 number or base 10 number to base 2 number, right? So generally what do we do? A base 2 number. For example, in this case, if the base 10 number, let's say it was given as 12. Now I want to convert this base 12 to this base 2 number. What is a base 2 number generally? What is a base 2 number? Base 2 number contains only two digits, either 0 or 1. It's a binary number. Now, generally the base 10, which is decimal number generally. Okay, if you want to convert into base 2, so what do we do? So what we do is we keep on dividing by 2. Okay, so 12 divided by 6, right? So 2 6 are 12. So we got 0 as a remainder, right? We got 0 as a remainder. Then we divide this number again. 2 3s are 6. We again got 0 as a number. So if we divide 3 by 2 now, we are going to get 1 as a remainder, and the quotient will be, we have to write the quotient here, right? Quotient will be 1. Okay. Again, if we divide by this one, so 2 zeros are, right? And what will get remainder as 1, right? So we have to start from bottom to up, and this will be at the base 2 number. That is a binary representation of 12. Okay. So 1100. So this will be the representation of in base 2, right? The binary representation. Now, generally, the base 10 number, which is decimal number, right? So what it contains? For example, what the digits contain, right? So it contains, if you see, right, one starting from 1, right? 4, 5, 6, 7, 8, 9, and 10. And again, the next number starts with 11, 12, 13, 14, 15, so on till 20. So it again starts, right? So in this way, this is a base 10 number. Now, if you look at the baseline number, right? Let's see the baseline number as well. Okay, the baseline number. So the baseline number starts with what? 1, 2, 3, 4, 5, 6, 7, 8, and it does not contain 9. Okay, it does not contain 9. Okay, so it does not contain 9, and the number again starts with 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, okay, 18. Then 19 definitely does not have 19. Then it starts with 20 and so on. Like this, it will go on. Okay, like this, it will go on. Okay, so this is exactly what we want. If you see, right, if n equal to 9, if the question had asked us, right, what is the ninth natural number? Okay, okay. So if you see the ninth natural number without the numbers containing 9, right? So if you see 1, 2, 3, 4, 5, 6, 7, 8, and 9. So this was the answer, right? This was the answer. The 10 was the answer. Okay. So now the solution is to whatever the number is given as 9, right? So we want to find the baseline number of the given number. Okay, the baseline number of the given number. So how we will how we will find the baseline number? So similar to what we had done for this, right? Same we have to do for baseline number as well. So let's say the number n was given as 50, let's say 51. Okay, the number n was given as 51. So let's take 51 here. So like base 2 to in order to convert into base 2 number, so we had divided by 2, right? So here we are going to divide by 9 here for the baseline number. So 9 fives are 45, right? So quotient will come here and the remainder will come here, 6. 6 is the remainder, right? So 9 fives are 45. Okay, 51 minus 51 minus 45, it gives us 6. 6 is the remainder and 5 is a quotient, right? Again, we'll divide this, right? 9. So 9 zeros are 5, right? That's all, because 5 is smaller, right? So, okay, so, and what will be the remainder here? Remainder is going to be 5. Okay, so now similar to what we had gone, right, from bottom to up. Here also we'll go from bottom to up, which will give us 5, 6, 56 as a number. 56 as a number, which will be the answer. Okay, which will be the answer. Okay, so this will be the 51st natural number, okay, with digits not containing 9. Okay, so this is the intuition behind solving the problem. Okay, I hope you have got the intuition. I think you'll understand better once we code. Okay, before going to the code, I'll also request you to subscribe to my channel. It will really be helpful to me and motivating to me. Thank you so much. So let's quickly code. So first I'll show the Java code followed by C++. So let's take the base 10 number first. Okay, the base 10 number, okay, which will be n, right? Which will be n, and the base 9 number, which will have base 9 number will initialize it with 0. Then we'll have this position. Let's take it 1 for now. I'll explain why we need position. Okay, so now what we're going to do, so while base 10 number will run a while loop till base 10 number is greater than 0. Okay, till base 10 number is greater than 0. Now what we're going to do here, so we are going to base 9 number, we are going to keep on accumulating this baseline number, right? Baseline number, how? So for example, um, this will be what? Position into, I'll explain this, what we are doing here. So base 9, base 10 num, okay, base 10 num mod 9, mod 9. So what we are doing here is, so let's say, right? So this was a 51 here, right? Sorry. This was a 51 year and we divide by 9. Okay, so what we want to do is ultimately the answer, what the answer was. For example, 5 was a quotient, 6 was the remainder, right? And 0 was a quotient and 5 was the remainder, right? So the answer was what? 56. Answer was 56, right? So what we are going to do is that we are going to take the remainder first, 51 mod 9. So what is the remainder? 51 mod 9. The remainder is 6, right? 51 mod 9, the remainder is 6. So first we are adding 6 to this baseline number. So base 10 number 51 mod 9 will give us 6. Okay, and position is what? 1. Position is 1. So now baseline number contains 6 here. Okay, now the next thing what we are going to do is we are going to also divide this number, right, by 9, right? That's what we are going to do, right? So 51 divided by 9 will give us 5. We want quotient, right? So now 5. And also with this, we are also going to increment this position with 10. Okay, we are going to multiply with 10. So now the position will contain 10. So why we are doing, why we are multiplying this position by 10? I'll explain that. So what we are doing, for example, now with the quotient was 5 and we want to divide this 5 with 9, right? So in this case, the remainder is going to give us what? It is going to give us 5. Now we want the answer as 56, right? 56 we want the answer as. We right now we have answer as 6, right? And we want this 5 in this position, right? The 5 in this position. So how we are going to get 5? So we are going to get 5 with multiplying by this position. Okay, for example, now base 10 number, after doing this operation, right? After doing this particular operation, what we got as a base 10 number? We got number as 5, right? We got number as 5. Okay, we got number as 5. Now what we are going to do? We are going to take mod of this 5 mod. So what we're going to do, we are going to, so we got the quotient 5, right? Base 10 number contains 5 now, and we are going to take mod of this, right? Mod of by 9, mod by 9. So we are going to get what? Remainder is 5, right? Remainder is 5. So this remainder is 5. So what we're going to do now? Position, position contains what? 10. So we are going to multiply this by this 5 by 10. So we are going to get what? 50, right? And in the base 9 number, we already had 6. So we are going to add 6 here, which will give us 56 as the answer, right? So if you see, that's what we are doing, right? Whatever is the remainder we got 5 mod 9, we got remainder as 5, and then we are multiplying by position which contains 10, right? So 5 into 10 will give us 50, plus base 9 number already had 6 in it, right? So 50 plus 6 will give us 56. Okay, and post this, once we do this 5 divided by 9, it is going to give us 0 in the base 10 number, and will break out of the while loop. And finally, we'll return this base 9 number, base 9 number. So this is the intuition behind, this is a solution. Okay, I hope you have got the solution. Let's compile. Okay, we got some, okay, we want long, long, long and long. Okay, let's compile it. Let's submit. The test cases are being processed. I'll request you to subscribe to my channel, like the video. Let's quickly see the C++ code as well. So here's the C++ code. It's same, like nothing to show in it. It's same, whatever we have done, right? Whatever we have done, it's same. Okay. So thanks for watching. Please subscribe to my channel, like the video. Have a happy, healthy, and a great day. Thank you so much.